Hello, so today I'll be teaching you transporting plants. So basically when you're talking about transporting plants, you have to keep the three processes in mind: diffusion, osmosis and inhibition. Diffusion is no longer in your syllabus, so today I'll be teaching you osmosis. So before we go into osmosis, there are a few things that you have to remember, like what do you mean by a solution, a solute and a solvent. Basically, when you add solute to a solvent, what you'll be getting is a solution. So if we talk about the concentration of a solution, it is always regarding the amount of solute present in the solvent. For example, if I take two glasses A and B, in glass A, I am adding 2 spoons of salt, and in glass B, I am adding 5 spoons of salt, and if I add equal amounts of water, the concentration of solute will obviously be greater over here. That is, solution B will have a higher solute concentration. But whereas in A, I will be having low solute concentration. So, osmosis is a process in which there is movement of water from a region of low solute concentration to a region of high solute concentration. And this movement always occurs through a semi-permeable membrane. The things you have to keep in mind is it always occurs through a semi-permeable membrane, and the movement of water is such that it always moves from a low solute concentration to a high solute concentration. In order to understand this process better, let's do a simple experiment. First, we're going to take a beaker filled with water. Then we're going to take a thistle funnel which has been inverted. The base of the funnel is covered with a semi-permeable membrane. From one end of the funnel, we're going to add sugar solution. Mark the initial level of sugar solution in the funnel. So according to osmosis, what happens is water moves from a region of low solute concentration to a region of high solute concentration. So in this case, water has low solute concentration, whereas sugar has a high solute concentration. So that means the movement of water will be from the beaker towards the funnel. So after some time, what we'll notice is that the level of solution inside the funnel has increased. So this shows what osmosis basically is. That is, it is nothing but the movement of water from a region of low solute concentration to a region of high solute concentration to a semi-permeable membrane. So regarding osmosis, you have to keep a few things in mind, like let's say there are 3 solutions: hypotonic, hypertonic and acetonic solutions. Hypotonic solution means a solution whose concentration is less than that of the cell sat. Hypertonic means a solution whose concentration is more than that of the cell sat. Acetonic means a solution whose concentration is same as that of the cell sat. So if I place a cell in a hypotonic solution, what happens is the water starts entering the cell. So this cell increases in size, and this particular process is known as endoosmosis. Suppose if I place a cell in a hypertonic solution, what happens is the cell starts to lose water. That means it shrinks in size, and this process is known as exoosmosis. But if I place a cell in an acetonic solution, the movement of water will be same in both directions. So the cell will neither increase or decrease in size. The next process is imbibition. Imbibition is the absorption of water molecules by certain molecules present in the cell. In order to understand imbibition, you can do a simple experiment. Take a box or a tin jar, place seeds in them. Add water. Then what happens is, due to imbibition, the cells start to absorb water. When they start absorbing water, it increases in size and the tin can will burst open. So imbibition basically means the absorption of water by certain molecules present in the cell. Osmosis and diffusion play a key role in the absorption of water. So, when we're talking about transport in plants, not all water is always available for the plants to be absorbed. So, generally, when we're talking about water which is available to the plants, they can be gravitational water, capillary water, runoff water, combined water, and hygroscopic water. Gravitational water means, for example, what happens is, after rain, the water moves deep into the soil and reaches the water table. This water cannot be absorbed by the plants. So gravitational water is hugely or deep into the soil because of the force of gravity, and it is no longer of use to the water. Capillary water exists in the interstitial spaces between the soil particles. So if these are soils and the spaces over there, the water present in these spaces are capillary water. And this water can be absorbed by the plants. Again, runoff water. If there is a rain, not all water reaches down to the water table. Some of the water, it always flows off the surface. This flowing of water is known as runoff water. Again, this is of no longer use to the plants. When we're talking about combined water, what happens is, water combines with the soil particles itself. So this water is also again of no use to the plants. Hygroscopic water means water which surrounds the soil particles. If this is soil particle, then the water is completely surrounding the soil particles. So again, this water is no longer available to the plants. So among these water, the only water which is important to the plants is capillary water. So remember, Pollard is the total water available to the plants. SI is the water which is absorbed by the plants, and HI is the water which is not absorbed by the plants. So out of these three, SI is the water which is absorbed by the plants. So, since water is absorbed by the plants, it has to move to the different plant parts. So, the many theories which have been provided to show the movement of water. Again, this can be studied on the two headings. Vital force theories and physical force theories. Vital force theories, what they state is, the movement or absorption of water is due to the activities of the living cells present in the plant, hence the name vital. Many scientists have provided proofs for vital theories. The first one is Bose. Bose, what he did was he conducted a simple experiment in which he showed that deep within the cortex of the stem there are pulses. These pulses can either be expansion or relaxation of the cell. And due to these expansion and relaxation of the cell, water can move through the xylem vessels. Another scientist, Westermeyer, he also believed that the movement of water through the xylem is due to the parenchyma cells surrounding the xylem. So again, parenchyma are the living cells, hence they belong to the vital theories. And then another scientist, Gordlewski, his theory is also similar to Westermeyer. Again, he states the same thing. Due to the activity of the parenchyma cells close to the xylem, the water moves through the xylem. So all these three scientists, Bose, Gordlewski and Westermeyer, they believe that the transport or absorption of water is due to the vital activities of the cell. But these theories are no longer applicable because a simple experiment in which the living cells of the stem have been killed, you can still observe the movement of water through the stem. In order to understand this experiment, what you will do is take a cut end of a stem, place it in a petri dish containing picric acid. Picric acid, what it does is it kills the living cells of the stem. Take the same stem from the picric acid and place it in a beaker containing water. You will still be able to observe the movement of water through the stem. So this proves that living cells are no longer involved in the absorption of movement of water. So vital theories are no longer acceptable. Among the physical theories, the most common one is root pressure theory. By root pressure theory, what it means is pressure exerted on the roots enables the movement of water through the root cells and up towards the stem. In order to understand the root pressure theory, you can do a simple experiment. Take a cut end of a stem, connect it to a tube containing water and manometer. So due to the pressure exerted on the roots over here, the water is pushed upwards and and due to the pushing of the water, you can see an increase in the readings of the manometer. So root pressure plays an important role in the transport of water in plants. Again, there are further proofs of root pressure theory, like you have all heard about guttation. Guttation is nothing but the loss of water molecules from the edges of the leaves. And this loss of water to the edges of the leaves occurs through special pores called hydrathodes. So again, your guttation is due to root pressure. Another process which you have heard is bleeding. If you cut a stem, what do you observe? Sap starts to exude. Again, the exudation of sap due to an injury to the stem is also due to root pressure. Another theory which supports physical theories is the atmospheric pressure. Atmospheric pressure, what it does is, atmosphere exerts pressure on the root cells, and the root cells enable the water molecules to move through them and finally to the stem. But atmospheric pressure is not applicable in tall trees. The most widely accepted physical theory is Dickson and Joyce's adhesive and coercive theory. Adhesive means it's a force of attraction between different molecules. Coercive means it's a force of attraction between same molecules. So generally, water exhibits strong coercive force among itself. It also exerts adhesive attraction towards the cells present in the xylem. So according to Dickson and Joyce's theory, what happens is, due to the strong coercive force among the water molecules and the adhesive force between the cells and the water molecules, water tends to move towards the stem. In order to understand this better, he also proposed certain conditions like the xylem exists as continuous numerous pipes without any breaks in between. So just think, if there were any breaks, water would move only up to a certain height. But that is no longer applicable because xylem exists as a continuous strand. So hence, there is easy movement of water through the xylem or stems. This can also be demonstrated experimentally. Let us take a beaker containing water. The tube is connected at one end to the beaker and the other end is connected to a sponge. You can observe that the sponge loses water through evaporation. You can compare the sponge with the leaves, this glass tube with the stem, and this water as salt water. So basically, this proves physical theory is occurring. But if you remember one thing in mind, like your root pressure, atmospheric pressure, Dickson and Joyce theory, or your root pressure theory, what happens is, all this movement is due to transpiration. Transpiration is a process in water that is lost from the leaves, and this creates a pull or tension throughout the plants. So this helps in the movement of water towards the entire plants. So thank you.